We are going to start with mathematical induction. First of all, we are going to do the first principle of mathematical induction. Okay, first principle of mathematical induction. This involves 3 steps. First step is that you have to prove that P of 1 is true. Okay, then you have to assume that P of k is true. Okay, given the first of all, it's given to you that P of n is a statement. P of n is a statement given to you, and you have to prove that P of 1 is true. You have to assume that P of k is true. Okay, whatever is statement given. And then third one is that using these two, using 1 and 2, you have to prove that statement is true for n is equals to k plus 1. That is, P of k plus 1 is true. Fine, you have to prove this. If you prove this, then the statement is true. Okay, otherwise the statement is false. So this is the first principle of mathematical induction. There is also one second principle, but both are same. So we are going to take just an example about this. So one example, let's say you just the simplest example, 1 plus 2 plus 3 plus 4 plus, so this is the sum of n natural numbers. It is nn plus 1 by 2. This is given to you. This is the whole statement. Okay, now you are going to prove that this is true. Okay, we are going to check this. So the first principle of mathematical induction says that the steps given to you are what? First, P of 1 is true. So let's solve this. P of 1 on the LHS side is 1. Okay, this is our LHS side. For the RHS side, P of 1 is what? N. Instead of n, you are going to put nn plus 1 by 2. So 1 into 1 plus 1 by 2. That will give you 2 by 2. That will give you 1. So P of 1 on the LHS side is 1, and on the RHS side is also 1. So they are equal. So P of 1 is true. So we have satisfied this condition. Now we are going to satisfy this condition. Assume that P of k is true. So we assume that P of k is true. P of k is true. That means what? P of k is true. That means P of k, that means 1 plus 2 plus 3 plus up to k will be equals to k into k plus 1 by 2. This is true. This we have taken in advance. Okay. Now third step is what? Assume using 1 and 2, prove that statement is true for n is equals to k plus 1. That is P of k plus 1 is true. Okay. Now we are going to prove P of k plus 1. P of k plus 1 is what? On the LHS side is 1 plus 2 plus 3 plus 4 plus 5 plus k plus 1. Now, this sum is given to you. From here you can say that this is k into k plus 1 by 2 plus k plus 1. Okay, this sum I have written k into k plus 1 by 2, and this term will be here. Now moving on, P of k plus 1, this is our LHS side. Okay, remember this. This will be k plus 1 can be taken common from the two terms. So that will be k plus 1 taken common, k by 2 plus 1. That will be k plus 1, k plus 2 by 2. Fine. LCM of this will give you k plus 2 by 2. Okay. Now, moving on to the RHS side. Now, P of k plus 1 on the RHS side will be what? P of k plus 1 on the RHS side. That will be, okay, first of all we'll see P of k. What is P of k? P of n is nn plus 1 by 2. So P of k is k plus 1 by 2. So P of k plus 1 will be what? P of k plus 1 will be instead of n you will put k plus 1, or instead of k you will put k plus 1. So k plus 1 plus 1 by 2. Okay, instead of k we have put the k plus 1 term. So that will give you k plus 1 into k plus 1 plus 1, k plus 2 by 2. This gives that RHS is equals to LHS. So P of k plus 1 is true. Fine. This is true, that means the statement is correct. Now, the second important point about mathematical induction is that if we are given TR, that is numerically the greatest term, then we use the second point about this is that if we are given TR, that is numerically the greatest term, then mod of TR will be greater than mod of TR minus 1, of course, and mod of TR, this TR is a term, rth term, okay, it is numerically the greatest term. Then you will apply this to prove that, and this T of R plus 1, that is if TR lies between these two terms, T of R minus 1, TR and TR plus 1, then if this term is the greatest term, then this will be greater than both these terms. Fine, both these terms, this term will be greater than both these terms. So, because it is the greatest term, so you will apply these two conditions and you will get obtain the desired results. Third point is to find the remainder when x to the power n is divided by y. Okay, try to express x or some power of x. Okay, either x or some power of x to the power k as ky. Okay, y is the denominator, so ky plus minus 1. Why is that? Because when you binomially expand this to the power something, okay, then you can get the common factor, the y as a common factor in each term, and the term which doesn't have it will be your remainder. Okay, so let's take for an example, let's take let's say 7 to the power 200 is divided by let's say 50. Okay, now we have to find the remainder of this theorem. So what do? We will express what are we going to do? We will express x or x to the power k, that is 7 or 7 to the power something, 7 or 7 to the power k something in terms of ky, that is k, or not k because I have used this, let's say m y, that is 50 plus minus 1. Okay, now we all know that 7 square is 49. Fine, and this can be written as 50 minus 1, so m will be there 1. Okay, so 7 square k is 2. Now 7 to the power 200 can be written as this. That's why this can be written as 50 minus 1 to the power 100. Now when you binomially expand this, every term will contain 50, but one term will not contain 50. Okay, I'm not gonna expand this because we are going to learn that in binomial theorem. So I'm just saying that if you expand this, every term except the last term will contain, or you can say first term will contain 50, and so when it is divided by 50, every term will cancel and there will be no remainder. Okay, so what we are going to do, we are going to divide every term with 50, and the remainder, we are not going to divide every term with 50, we are just going to divide the remainder with 50, and we'll see whatever it is. Okay, this term. So here the mathematical induction is O.